Hey guys, I'm going to do another couple of synthesis problems for you. Today we're going to look at what we have to do in order to get this molecule from benzene. Okay. Now, if you look at this, it kind of looks scary because you're like, whoa, I've never seen that before. How do I put that on there? We just got to take it down and think about it first. Now, we know that neither of these groups are going to be ortho or pair directing, so obviously we're not going to be able to start with that. So, what we're going to start with, actually, is ClCH3. You can start with any chain length of this, like you could do Cl and like, I don't know, a pentane group on there, and we'll still get the same thing. But for our purposes, we're just going to keep it short and sweet, and I'll explain that in a little bit. Okay, so we substitute on this methyl group. Okay. We know that methyls or any hydrocarbon is going to ortho or pair direct, and looky here, we want to pair direct, or ortho direct, sorry. So now we can just go ahead and put on our reagents here. Okay. And you'll get CH3 SO3H. Okay. Now, by the addition of potassium permanganate, KMNO4, it will oxidize this methyl and will give us our carboxylic acid. And we look back at what we were supposed to synthesize, and I think we hit it the nail on the head. Or if you didn't know, which I hope you did by now, but this is the same thing as this. If you want to look at some of the earlier videos to figure out how to do that, go back and look down. I think it's like episode 3 or 4 where we talk about how to draw the Lewis structures. Okay, in a couple of videos ago, we did some Friedel-Crafts alkylations, and well, I think we just did one example. I just kind of wanted to show you guys what would happen if we didn't go, like if we were trying to synthesize something different than what we did. Now, in our example, we'll do butyl benzene. So we're trying to get butyl benzene. Okay. Now, trying to do just a regular Friedel-Crafts. If you did this, you would get a rearrangement where when the chlorine left, you would end up with a rearrangement with a 2' carbon. Yeah, so what will happen is, like, you'll have you'll get something like this. With this carbocation rearrangement instead of what you want out here, because this being 2' is more stable than this primary carbon. Okay, so we need to find a way to avoid that, and this happens with any chain of carbons that's more than 3 in length. Actually, if it's 3 in length, you're going to have to do the acylation, which is where you take a compound containing an alkene, a ketone, sorry, and you react it with the benzene ring. So I would do something like this. Sorry, I know this is terrible. This is going to be the only way that we're going to be able to do do any carbon or alkanes longer than 2 in length. Okay, so I'm gonna go ahead and get this out of the way. So yeah, we'll have to go ahead and react this with. It's going to be pretty much the same process, except we'll have one twist at the end there. Alright, so now this will substitute on, but we do have one problem. We have that ketone in there, which we do not want, because that is not what we're trying to synthesize. Yeah. So there's a way to get rid of that. Now there are 2 ways that we can create this into a total hydrocarbon, and they're called the Clemmensen reduction or the Wolff-Kishner reduction, and they do the same thing, both of them. It's just different reagents. Personally, I like the Clemmensen because it's easier to write. So I'll show you. So if you just add zinc, mercury, and HCl, it will turn that ketone, it will reduce it, and you'll get a total hydrocarbon chain. Okay. Now the other one is NH2, NH2 with OH hydroxide, and both of these require heat actually. So I guess it's not really hard to write. I don't know. I just like the zinc mercury better. Alright. Okay guys, this is similar to one of the ones we did on maybe part 1 or part 2. I'm going to go ahead and let you pause it and create this molecule from benzene. Okay, to start out with, we're going to go ahead and alkylate this. Okay. Giving us this little group. Let's go ahead and oxidize it. My handwriting degenerates as it gets later, guys. Sorry about that. Okay. And then, so now this is going to be meta-directing, and we can add our nitrate group, our nitric acid. Oh goodness, leaving out stuff. Alright. Yeah. Sorry. Whoops. That is not where it's supposed to go. That's meta-director. NO2. Alright, I'll do one more example for you guys. Okay, this one's going to be fairly straightforward. Basically what you're going to want to do is alkylate it. Okay. Now, as we discussed earlier, adds on methyl. Now this will ortho or para direct, and obviously we want para, so that's what we're going to stick with. And we can go ahead and add our bromine on this stuff. Okay, and now we can go ahead and oxidize. Alright, and there you go. Have a nice day, guys.